Good day everyone, and once again we are back together. All right, so we are looking at that Euclidean geometry, and so if you have not subscribed, please make sure that you're part of the family. All right, so let's get right into it. So we're looking at a question that I took from a past exam question paper. So what do they say here? They say M is the center of the circle. Now remember guys, in the previous videos, I had shown you that whenever you've got a center to a circle, right? So what are we going to do? Just indicate those radii, isn't it? Okay, so we know that it means that MR will be equals to MQ. That will be equal to MV. That will also equal to MS. And why is that? Because all of those are radii. Okay, right. So, and they say to us, they have chords SV and QR. They have equal chords. So we note that SV is equals to QR. Okay, and they say R and QP are tangents in the circle. Now remember, we did say that if you've got two tangents that meet at the same point outside the circle, then what do we note? That those tangents would therefore be equal. So in this case, it simply means that this guy is equal to that guy. RP would be equal to QP. And you can also note that that makes a triangle PQR an isosceles triangle. Okay, I'm sure by now you know this. Okay, right. So they want us to determine the size of R2. Okay, so let's start where we are, right? So I'm going to say in triangle PQR. Can you see that we know that? Okay, let's write it down. So in triangle PQR, we know that PQ is equal to PR. Is equal to PR. But why is that? Right? We say these are tangents that meet at a common point outside the circle. Right? So these are tangents from the same point. All right. And so because they are equal, so therefore triangle PQR is isosceles, isn't it? So that's an isosceles triangle. So therefore it means that R2 is equal to Q2. R2 is equal to angle Q2 is equal to R2. And in this case, why is that? These are base angles of an isosceles triangle. So base angles of isosceles triangle, right? Now, please, I want you to note, if we decided to call either one of them, let's call Q2X. That means R2 will be equal to X. So therefore, angle P plus angle Q2 plus angle R2 is equal to 180. And why is that? We know that this is angles on a triangle. Okay, sum of angles on a triangle. So we know that angle P is 70 degrees. We were given that. Okay, or what they called RPQ, right? And Q2 is X, and we said R2 is also X, and that's equal to 180. Okay, so which means 2X is equal to 180. We're going to subtract that 70 when we take it to the other side, right? So that gives us 110. Okay, and if we divide both sides by 2, X will be equal to 55 degrees. Okay, so that is how this cookie crumbles. All right, let's go to Q1. How are we going to get the value of Q1, right? Now, ladies and gents, I want you to please note in this case, what usually becomes, I think a challenge, or many people tend to make that mistake. They want to say, oh, well, but I suppose we could use the 10 chord theorem, right? Now notice, here's our chord, but can you see that that angle does not reach, right, the circumference of the circle, right? So in that case, we could not, or rather we cannot use the 10 chord theorem, right? So now what are we going to do? We're going to have to devise a plan. All right, so our plan is that, remember, we've got a center, right? And what do I know in that case? I know that any angle from the center that meets a tangent at a point of tangency, it will definitely be perpendicular, right? So what does that mean? It means that entire angle there is equal to 90 degrees. So ladies and gents, all right, so if I look at angle MQP, so MQP is equal to 90 degrees. But why is that? We say this is the 10 perpendicular to radius. Okay, so that means Q1 plus Q2 is equal to 90 degrees, right? That's the entire angle MQP rather. We just found out that Q2 was equal to 55, right? So that means Q1 will be equal to 90 minus Q2, but we know that's 90 minus 55, right? And as a result, it means that Q1 will be equals to 35 degrees. Okay, I hope that makes sense, ladies and gents. And essentially, that is how the cookie crumbles, right? Okay, so we found Q1 this time around. Okay, so we know this is equal to 35 degrees. Right, now, how are we going to find the value of M2, right? Now, please, I want you to note, ladies and gents, we can find the value of M1, right? So how are we going to do that? We're going to say, well, in triangle MQR, right? We know that MQ is equal to MR, Y, the radii. Okay? Now, because those are equal, therefore it means that triangle MQR again is isosceles. I hope you guys are beginning to appreciate how these isosceles triangle play a role in how you solve Euclidean geometry, right? So in this case, what does it mean? It means if these two angles, so therefore it means angle Q1 is equal to R1, which is equal to 35 degrees, right? And why is that? These are base angles of an isosceles triangle. Okay, right. Now, how am I going to get the value of M1? So that means M1 plus Q1 plus R1. This is equal to 180. These are angles on a triangle. All right, just for the sake of space. So that means that M1, you are going to just use your algebra there. So M1 will be equal to 180 minus 35 times 2. It's R1 and Q1, right? So this is going to be 31 times 2, which is going to be 70 degrees, right? So that means that M1 is 110 degrees, right? Now, ladies and gents, I want you to please appreciate the fact that, now I want you to note, we said those angles were 35 degrees, right? So both of them made 70 degrees, and so M1 is 110. But please do note that M1 is equal to M2. Now note, we do not say they are vertically opposite. Remember, these two are not straight lines, right? However, these are angles subtended by equal chords, right? So please remember that, okay? But M1 is equal to M2, okay, which is 110 degrees. And why is that? These are angles subtended by equal chords. All right, now please remember that, okay, that if we are subtended by equal chords, then it means that those angles are therefore equal. So we got the value of M2 to be equal to 110. I hope that makes sense, ladies and gents. I'm going to come back with some more. Right, so let's try this other one. So they say to us in the diagram below, O is the center of the circle. I'm sure you guys have now figured it out, right? The moment they tell us that we've got a center, what do? We just mark out those radii, right? So that means that OB is equals to OD, that equals to OA. Right, and then they tell us that, okay, so let me just bring this down. Let's say CDE is a tangent, okay, to the circle at D, right? So note, again, we've got a line from center that meets with the tangent at the point of tangency. So we know this has to be 90 degrees, isn't it? Right, so that has to be perpendicular. That's our 10 radius. Okay, so in this case, they say that DB bisects ABC. Right, so there is angle ABC, right, that entire angle there, right? But they said that DB bisects it, so that simply means those two angles B1, right, would therefore be equal to B2. Okay, now they say to you, let B1 be equal to X. So what I like doing is, all right, let's work with B1. So B1 is X. So meaning which other angle would be equal to X? So that means that's equal to X. Can we find other angles equal to X? Of course, that means also D1 is equal to X. Remember, that makes OBD an isosceles triangle, right? So as a result, it means that that is equal to X. But I want you to note, you've got triangle OBD. This is an exterior angle of a triangle, right? So we can say that this is actually equal to 2x. All right, I hope that you get that. So that would be equal to 2x, or 1 is equal to 2x, because it will be B1 plus D1, right? So those two being equal to each other, right? So O1 is equal to 2x. That's an exterior angle of a triangle. Alternatively, you could also use angle at center is twice angle at circumference, seeing as it's subtended by that chord AD. When you get to the center, we've got O1. When you get to the circumference, we get B1. So you could also use that theorem there. All right, and let's see what it is that they want us to determine here. They say prove that BC is parallel to OD. Now, let's do this, ladies and gents. They want us to prove that this line over here, BC, is parallel to OD, right? Now remember, we are proving, right? And in order for us to prove, it means that we need to use any other information. We cannot assume them to be parallel. So, which means we either have to prove that alternating angles are equal, or we have to prove that corresponding angles, right? Remember, corresponding angles also equal. Or in this case, we can prove that the co-interior angles are supplementary. Okay, right, so let's start. Right, you remember, where did we start? We said B1 is equal to B2. I can already see that B1 is equal to D1, and that makes it alternating angles, right? I hope you can see that there. If those angles are equal, therefore it means those lines are parallel. Okay, right, so let's do that. So they say to us, we are going to say, right, we knew that B1 is equal to B2. Remember, why is that? Which is equal to X. We said the reason for that. Well, the reason for that is given. Okay. Remember, it was given that line BD bisects ABC. Okay. Right. So that is given to us. And so in this case, we know that in triangle BOD, right, OB is equal to OD. And why is that? They are radii. Okay, so that means therefore triangle BOD is isosceles. Beautiful stuff. So it's that is an isosceles triangle. So therefore we can say that B1, angle B1 will be equals to D1. And why is that? These are base angles of an isosceles triangle. Okay, and by the way, because those are equal, so therefore it means that B2 is equal to, okay, that was supposed to be equal to X. So B2 is equals to D1, right? And so therefore it means that BC is parallel to OD. Why? Right? Why are they equal? Because in this case, alternating angles are equal. Okay, so the converse of alternating angles are equal. So note, ladies and gents, we proved alternating angles equal and therefore concluded that the lines are parallel. All right, so that is what is required. Now they say to us, we must show that angle C is equal to 90 degrees. Right, now let's quickly do that, ladies and gents, right? So we just found out that this angle here, all right, so we know that that angle is equal to 90 degrees over there, right? Now how I'm going to actually go about that one is for 11.2, I'm going to say that if you look at D1 and D2, which means that entire angle, that is equal to 90, right? And why is that? So D1 plus D2 is equal to 90 degrees, right? We said this is 10 perpendicular to the radius. Okay, right. So in this case, we know that the tangent is perpendicular to the radius. We know that D1 is already equal to X, and so that means that D2 will be equal to 90 minus X, right? So which means this smaller angle over here is 90 minus X, all right? And because that whole angle was 90, so it means that to find that smaller angle D2, that will be 90 minus X, because this we've already established is equal to X, right? But then we go into triangle BDC, okay? So B2 plus D2 plus angle C, that will equal to 180. Why is that? Angles on a triangle. Okay, So we know the value of B2. We said B2 is equal to X. We know the value of D2. That's 90 minus X plus the value of angle C. And this is equal to 180. So if you notice, these two are going to cancel. So C will be a 180 rather minus 90. And this is equal to 90 degrees. And so we've proven that angle C is equal to 90 degrees. Right, if you wanted perhaps an alternative way that you could have done that, okay, you could have taken the root of finding this angle, right? So this angle over here, this is 90, this is X. So this entire angle, okay, let me give it a different color. This entire angle would be 90 plus X. And so that becomes the exterior angle in that triangle, right? And you know that the exterior angle is equal to the sum of the opposite interior angles. So the exterior angle is 90 plus X. This one is X, so that's, therefore C has to be 90 degrees. So that's another a way in which you can find that angle. Ladies and gents, I hope that you were able to follow on this. I'm still going to be giving you more and more content on Euclidean geometry. I hope that all my grade 11s, right, you are enjoying this. And for those of you that are in grade 12, this is also relevant for you, okay? But otherwise, from me for now, I'm going to see you guys next time, and we'll do even more complicated questions on Euclidean geometry. From me for now, it's sharp for now.